All right. Good morning, everybody. Let's go ahead and start this lesson out by doing a little bit of review. So let's go ahead and grab your problem set, and let's do numbers 2, 3, and 4 from the chapter 9 problem set. So let's start out with a quick review because we can go ahead and use that. Today we're going to continue talking about how we can name ionic compounds. We're going to talk about naming binary compounds, and then we're going to name the non-binary ionic compounds. And so, in order to be able to name them, we have to be able to recognize ions and also how they form. Okay, so with that said, let's take about 2 minutes. I don't think it should take you too long to do number 2, 3, and 4 in the chapter 9 problem set. So grab your paper. And so on your paper, I'd like you to show me, answer the questions 2, 3, and 4 from the chapter 9 problem set. And then we'll go over it once you get back. So take about 2 minutes, work on the numbers 2, 3, and 4, chapter 9 problem set. I'll see you back here. And then we'll go over it, and then we'll start talking about the naming and working with naming these ionic compounds. Okay. All right. Take about 2 minutes. Go ahead and get those 3 problems done. Okay. Hopefully you got it done. Let me go ahead and let me open up the whiteboard here, and let's take a look at. Let's see. Yeah. Let's go ahead and let's take a look at these 3 problems. So let's do numbers 2, 3, and 4 from the chapter 9. Go ahead and open that up. Yeah. Okay. Chapter 9 problem. Let's go ahead and work these out. Okay. All right. So for number 2, they asked us to basically just write down the composition of these particular atoms. These atoms then are ions. Okay, so they give us the ions of these atoms here, these ions here. So let's go ahead. Let's take a look at the first one. Okay, so let's do number. So this is number 2. Sorry, number 2 in the chapter 9 problem set. Okay, so first of all, they give you the names of these ions. Please make sure you're able to write down the symbols for each one of these ions here, because we have to be able to do that. Today, hopefully we'll be able to get to it today. If not, we'll get to it tomorrow, where we are given the name of the compound. I'm sorry. Today we'll be working with names of these ionic compounds. So if they give us the names, we have to be able to write down the formula. Okay, and also if they give us the formula, we have to be able to write down the name. So again, hopefully today we'll be talking about if they give us the we'll be going over formulas. If they give us the formulas, can we write out the names? But hopefully today, if not today, we'll get to it tomorrow, where if they give us the name, we should be able to come up with the formula. And the way that we do that is that we have to be able to identify the ions. Okay, we have to be able to write out the names of those ions. I'm sorry, the formulas of these ions, and then do the crossing the charts that we did back last week. And so you have to be able to do that. So that's why I wanted us to practice it. So number 2 here, they give us the names of these ions here. We have to be able to write out the ions, the symbols for these ions, and then be able to identify them. Okay, so let's go ahead and let's take a look at the first one. So with the magnesium ion, okay, so hopefully you recognize then that this being a metal, okay, that this is going to be a cation. Okay, and so with this particular ion, then okay, we have that it's magnesium. So with magnesium, then we should expect then that we should have 12 protons. Okay, all right. Now magnesium ion, if you take a look at it, neutral magnesium then would have 12 electrons. Okay, would have 12 electrons. In order then to identify the number of electrons that it has, we have to remember what type of ion that magnesium forms. Magnesium is a 2A metal. Okay, magnesium is a 2A metal, which means that it has 2 valence electrons. 2 valence electrons. In order for magnesium to obtain the noble gas configuration, remember magnesium will, because it is a representative metal. Okay, in order for it to become in order for it to obtain noble gas configuration and thus adhere to the octet rule, it's going to lose those 2 valence electrons. And if it loses the 2 valence electrons, it ends up with 10 electrons. Okay? And that would then be the composition of the magnesium ion. Now, It doesn't ask you to do this. It doesn't ask you to do this, but hopefully on your paper, what I'd like you to do now also as we go through this is write down the symbol. Okay, so in this particular problem, they only ask you to write down the composition of each one of these ions here. But I would like you to do this here. Okay, so that's the magnesium ion. Okay, that's the composition of the magnesium ion. What I'd like you to do then is, if this is the composition of the magnesium ion, what would the formula, what would the symbol for the ion be? Well, we talked about this. So it's magnesium, so it should have the symbol for magnesium. Okay, so it's magnesium, so it's going to have the symbol for magnesium as well. Okay, Mg. However, this is not the elemental magnesium, because elemental magnesium would have 12 protons and 12 electrons. This particular atom here has 12 protons and 10 electrons, and so therefore it will have a 2+ charge right here. And that's what's going to make it different from the elemental magnesium. So you have to be able to write down this symbol. So for what we will hopefully be doing today, and if not today, tomorrow, you'll need to be able to write down the symbol for each one of these ions here. Okay. All right, let's take a look at the next one. Okay, we have the bromide. Okay, ion. Okay. All right, now this, hopefully you will be able to recognize, and this is why we're practicing this, okay, that this is a non-metal ion. Okay, this is a non-metal ion. Okay, first of all, you should be able to recognize then that the suffix here, okay, the suffix here indicates then that this is an anion right there. So you will look for the IDE ending, and that's what you have to be able to do. Look for that IDE ending. That means then this is going to be an anion. Okay, so we know then that this is going to be an anion from the bromine. So this is going to be the bromine from the bromine atom, which means then that we start out with 35 protons. Okay, so this is bromine. It says 35 protons. Okay. Now, the bromide ion, remember, bromine is a 7A metal. I'm sorry, 7A non-metal. As a non-metal, remember, in order for it to become stable and adhere to the octet rule and thus obtain a noble gas configuration, it's going to gain electrons. But as a 7A metal, it only needs one more electron. So 7A metal, sorry, it's a 7A non-metal. As a 7A non-metal, it's only going to need one more electron to complete its octet. Okay? So therefore, it will end up with 36 electrons. Okay? So that would be the composition of this particular atom that we call the bromide ion. So same thing here, real quick, if on your paper while I'm walking you through this, go ahead and write out the symbol for the bromide ion, an ion that should have, an atom now that should have 35 protons. And if it's 35 protons, it has to be bromine. It's a bromine atom, but it's a bromine atom that has one extra electron. And so therefore the symbol for this particular atom then will be Br-, and that's going to be the symbol for the bromide ion. Okay? All right, let's go ahead and let's take a look at strontium. And go ahead and write down the symbol for strontium as I'm writing this out for you as well. So the strontium ion, strontium, hopefully you recognize this as well as you're doing this. This is also this is going to be a metal as well. This is a representative metal as also. And strontium then is also a 2A metal, which means then it will form a cation. It will also have to lose 2 electrons like magnesium does here. Okay? But the difference in strontium is element number 36. So it's going to have 36 protons. And if it loses 2 electrons, it ends up with 34 electrons. So that would be the composition of strontium. The symbol for the strontium ion then is going to be Sr, because this is strontium after all. But it has lost, I'm sorry, 38. Sorry. That's my fault. Strontium is 38. Sorry, let me go back here. 38, 36. So strontium is element number 38. Sorry about that. So 38 protons. What's going on here? Okay, 38 protons, and therefore it'll be 36 electrons that we have there. All right. So with that said, then it's going to be Sr with the 2+. That would be the symbol for strontium. Let's do the last one, sulfide. And again, real quick on your paper, write out the symbol for sulfide. Okay, while I work this out for you. So sulfide, hopefully you recognize this by the ending of the name, the ending of the IDE ending. As soon as you recognize that, folks, for monatomic ions, you should be able to see then that these will be the anions here. Okay. So with that said, it ends in IDE. We know that it's going to be an anion of some sort. It's going to be an anion. Okay. And so anion based off of the sulfur atom. The sulfur atom has then 16 protons, okay? And sulfur is a 6A nonmetal, and so therefore, in order for it to obtain the octet, it has to gain 2 more electrons in order to complete its octet. So it's going to gain 2 more electrons. It ends up with 18 electrons here. Okay, so with that said, then the symbol for sulfide ion is going to be based off the sulfur atom with 2 extra electrons. Therefore, its charge is going to be 2 minus. Okay. All right. So with that said, these ions here are what we refer to then as monatomic ions. Remember, these are what we refer to as monatomic ions, and you need to be able to differentiate this because remember, we have those polyatomic ions that you have to memorize. With the monatomic ions here, you can pretty much, given the name, be able to determine the symbol for these monatomic ions. You don't really have to memorize these at all. With the polyatomic ions, you got to make sure you memorize. Okay, so please make sure if any part of this right now that I'm going over with you, you don't quite get, please make sure you ask it, especially with the symbol, identifying the cation versus the anion, because in here, there is no mention of cation versus anion. They just give you the name. You have to be able to differentiate between which of these names refers to cations, okay, based on the name, and which one refers to the anions. Okay, so please make sure for these monatomic ions, you're able to differentiate and work that through. Okay. All right, let's go ahead then. Let's continue on. Let's take a look at number 3. Okay, the chapter 9 problem set. Number 3, then basically this time they give you the name, the symbol for the ion. And so what I'd like you to do then is just real quick on your paper again, just as practice here. If they give you the symbol for each one of these ions, I would like you to include the names real quick as I write this down for you. Go ahead and write out the names of these ions as well. Okay. All right, so hopefully you recognize that the ions that they give you in number 3 are again monatomic ions, very much like what we have here. But this time we're going basically in the reverse direction, where they give you the symbol and they want you to write the name. What we did in number 2 here was they gave you the name, we identified the composition, and then I asked you to write out the symbol. Okay, so here at number 3, they give you the symbol. So hopefully you had a chance to write it out. Let's go ahead and let's take a look at this. So for the very first one, we have an ion here with the symbol Fe3 plus. Okay, Fe3 plus. Okay. Now, they asked you whether these atoms here gain or lose electrons. These ions here gain or lose electrons, and hopefully that should be very simple for you. Okay, and then not only that, how many do they gain or they lose? Okay, so iron here is an element. Now I'm going to go ahead and do the composition here for you as well. So it is an atom that has 26 protons. It has to have 26 protons because it's iron. Okay? However, it has a 3 plus charge, okay, which means then it has more protons than it has electrons. Neutral, that is elemental iron, remember, should have 26 protons and 26 electrons. But this is not neutral. This is not elemental iron. It has a charge of 3 plus, which means then the number of electrons should be 23. We have 3 less negative charges than positive charges. So therefore, this particular atom then has lost 3 electrons. So this particular atom has lost 3 electrons, okay, in order to become this ion. Okay. All right. And so what is the name of this particular iron atom then? Okay. So with cations, remember, we just write down the name of the metal, okay, that it derives from. We can get that from the symbol. We write down the word ion or cation. Here I write down cation. Okay. All right. But this is a transition metal, which means then remember we have to include a Roman numeral that indicates the charge on that particular ion. Okay. And so therefore this is the iron 3 cation. Okay. All right. Let's go ahead and let's do the same thing for the next one. Okay. This is O2 minus, so this is an anion. Okay, so with so this is an anion that's that is based off of the oxygen atom. Okay? And so with the oxygen atom, then it has 8 protons. But in this particular atom, okay, that's elemental. For neutral elemental oxygen, then we expect that we should have 8 electrons as well. But this particular atom has an excess of 2 negative charges, has 2 more negative charges. So therefore, we should expect then that the ion formed for oxygen should have 10 electrons. And so therefore, in order for it to do so, we have an excess of 2 more electrons it has gained 2 electrons. Okay. All right. So that hopefully you're able to get that. The name of this atom then is going to be based off of the oxygen atom. But with that said, then since this is the anion, we only keep the O and the X. Oh, excuse me. The O and the X, and we're going to add an IDE, okay, to indicate that this is an anion, and then we write down the word ion. So this is going to be the oxide anion, oxide ion. Okay. All right, for the last one, let's go ahead and stick with the last one. We have then Cu plus. Okay. This is a copper ion. Okay. So this is an ion based off the copper atom. Okay. So since that's the case, then we have the 29 protons. It's copper. Okay. But it has lost 1 electron. Okay. I'm sorry. It has a positive charge. So therefore, the number of electrons should be 28. 1 extra, 1 less electron. Okay. So therefore, in order to become this ion, copper has to have lost 1 electron. Okay. All right, so with that said, let's go ahead and name this one really quickly. So this is a copper ion. It is a copper cation. But again, it's a transition metal. So in parentheses, we need to make sure then that we indicate in the Roman numeral using our stock system, okay, what the charge is on that ion. Okay. All right, very good. Let's go ahead. Let's do the last one really quickly, and I'm just going to go through this really quickly as we have to get started on the lesson for the day. Okay, so let's go ahead and let's take a look at number 3 here from the problem set. Okay, so number 3 then they ask us to write out the symbol for each one of these ions. I'm sorry, the symbol for the ions formed for each one of these elements here. So for the very first one, let's go ahead and let's take a look at this really quickly. Arsenic. Okay. Hopefully, arsenic is a tough one. Because arsenic is a non-metal, I'm sorry, a metalloid, and metalloids can behave either as metals or non-metals. But an interesting question came up. Someone came by, I think it was last week, asked about the metalloids, and it was an excellent question. That is, since metalloids can behave as both metals and non-metals, when they form, first of all, do they form ionic compounds? That was the question that the person asked, and the answer is yes. They do participate in ionic compounds. And so from that discussion, we talked about then how if they do, if they can form a part of an ionic compound, do metalloids tend to behave as metals or non-metals? That is, will they form cations or anions when they are part of an ionic compound? And the answer there is that for the most part, most of the time, they will behave like non-metals. I mean, they will gain electrons and they will become an anion. For most of the ionic compounds that we'll come across with metalloids, you'll see them behave as nonmetals. They will pick up electrons and they will become anions. Will there be the occasional ionic compound that will have a metalloid behaving as a cation and thus metal? Yes, there will be, but those are not as common. Okay? And so arsenic here being a metalloid, it's going to behave like a nonmetal. So if you're not certain, always assume then that the metalloid in an ionic compound will behave as a nonmetal. Okay. All right, so with arsenic then, if it's going to behave as a nonmetal, it's going to gain 3 extra electrons. Okay, it's in, and let me grab my book here really quickly. Yep. And so it is in column, it's in group 5A, so it's going to gain 3 electrons. Okay. And so therefore, in gaining 3 electrons, okay, it will get a 3 minus charge. So arsenic then will gain 3 electrons and it will become an anion. Okay. All right, let's continue on then. With that said, beryllium, okay, beryllium is a metal, so and it is a representative metal, a 2A metal, and so therefore we will know then that it's going to lose 2, and that's get the charge of 2 plus. Okay, all right. I'm sorry. So this will be your anion. So it will form an anion. This will form a cation. I'm sorry. With that said, let me just quickly go back to the metalloids here. With the metalloids, what you will typically see them participate in are less so ionic compounds. They will also you'll find them more often in covalent compounds, these molecular compounds, which we'll talk about in chapter 8. Okay. So with that said, let's take a look at the astatine, which is another metalloid. Okay. And like I said, these metalloids tend to form anions if they participate in an ionic compound. So there it is. There's another anion. Acetine is a 7A metalloid, and so it'll behave like the other 7A halogens, okay, and it will gain 1 electron. Okay. All right, the last one then, gallium. Okay. Gallium then is a 3A. It's a 3A metal, okay, and so therefore very much like aluminum, it's going to gain 3 electrons. I'm sorry, lose 3 electrons. It's going to lose 3 electrons, and this becomes cation with 3+ charge. So cation here. All right. So I know that we spent a lot of time this morning reviewing this, but folks, it's essential, and we'll be doing more of this as we go along. Okay, but it is essential that you know how to do this, that you are able to work these problems out, do this, do what we've done here. Okay, because if you can't do this, you got to practice it, because with these monatomic ions here, they're going to be critical when we talk about the binary compounds, which we're going to talk about in just a moment. But also when we talk about non-binary compounds, the cations, with the exception of one, remember, will always be monatomic ions. Now, with the polyatomic, with the non-binary compounds, then the anions, then for the most part, will be polyatomic. Okay? But like I said, hopefully you remember there is one polyatomic cation. So in our non-binary compounds, every compound, every one of those compounds will have as a cation a monatomic cation. Again, with the exception of one. Okay, so please make sure you're able to write out the formulas and symbols for these monatomic ions, because they're going to be important for what we'll be doing. Okay. All right, so let's go ahead then. Let's quickly review what we talked about yesterday. And we were talking about these ionic compounds. Let me go ahead and share with you my screen here. Okay, so we were talking about these ionic compounds. We said then that with ionic compounds, they come in 2 different types. Okay. We have then what are called binary compounds and non-binary compounds. Okay. And the binary compounds then are the ionic compounds that have 2 elements, okay, that have only 2 elements. And so what you need to be able to do when we work through this then is make sure then that you are able to identify that the compound is binary. Okay, so let's take a look at this first compound here. Okay, because what we want to do then is, if you're given a name or if you're given a formula, you got to be able to identify the binary compound. So here we have the formula. Okay? And so we're given the formula. What we want to be able to do is so we have to be able to, first and foremost, if we want to name it, we have to identify it as being binary. How do we know that it's going to be binary? We just count the number of elements, okay? Not the number of atoms. I want to make sure I'm clear on this. We have to see how many elements there are. So if you take a look at this one, there's one element right there, the calcium. Now, obviously, this calcium atom has become an ion, but we have the element calcium, then we have that metal, and then we have the second one right here, whoops, sorry, which is the sulfur, okay? The sulfur elemental sulfur right there. So with that said, that there are the 2 elements that participate in this compound. So is this compound binary? Yes. So we got to be able to answer these questions. Now, hopefully you don't have to do this, write it all out, but hopefully you're doing this in your head. Okay. All right. So in order, again, to name these compounds, okay, first of all, we're going to start out and we're going to identify whether it's binary. Binary just meaning then 2 elements. There's 2 elements that participate in this compound. And there it is. We have elemental calcium and elemental sulfur. We have the element calcium, the element sulfur. They both obviously had chains, and we talked about this early on last week. And so the quiz yesterday asked you to write out the ionization reactions showing how this compound forms. Please make sure you're able to do that. So I would challenge you that if you need to practice it, go ahead and show me how, write out the ionization reactions to show me how this compound forms, because you will see that on the exam next Monday. You got to be able to do that. Okay. All right, so with that said, what are we going to do? We're going to name the cation. Well, obviously here, hopefully you recognize then that the cation here is going to be the metal. The metal is always going to be the cation. This is a monatomic cation. And so therefore the name, in order to name it, we just go ahead and write down the name of the cation. So it's going to be then the calcium cation, okay, or the calcium ion, that's it. Okay. Now, the next question is, it will help you, because what we need to make sure we remember then is that with the transition metals, we have to have the Roman numeral in it. Okay, so if you notice here, this cation is not going to have the Roman numeral, so we don't need to include the Roman numeral in the name. Okay, so is it a transition metal? No, it's not a transition metal. We don't need to include the Roman numeral in the name of this compound. Okay, this calcium is a 2A metal. It's a representative metal. Okay, all right. So now that we've taken care of the cation, the anion then is always going to be the non-metal, and we have to name the anion. Okay. Now the anion is based off of sulfur. Okay, but remember, since the anion, we just practiced doing this, we have to make sure then that we include the suffix IDE. And with the anions, we will always include the suffix IED, but the root of the of the name of the element that we keep, the stem part of it, okay, will depend from element to element. Okay, so with oxygen, we saw then that we only kept the O and the X. Okay, with the halogens, we saw then that we dropped the last three letters and we add an ID. So it varies just a little bit, but as you practice this, you're going to see then you'll be able to recognize this. Okay, so with sulfur, then we're going to keep the first four letters as part of the stem, and then we add an IDE. So this is going to be the sulfide anion. Okay, all right. So there it is. We've answered the first four questions. The last question then is going to be easy, where we bring everything together and we name the compound. And remember, we did this back in last week. I think we did a little bit of this already. In order to name this compound, what we're going to do is we're going to take the names of the ions. Okay? We're going to go ahead and we're going to drop the ion, the part of the name that has the ion in it. So we'll drop the cation here, the anion, and so we'll end up with the name of this compound then, okay, as being calcium. And the way we write this is always we write down the cation first, the name of the cation first, followed by the name of the anion. So this is going to be calcium sulfide. And we basically follow the order that we're given here in the formula, with the cation first and then anion. So in the name, we'll write out the name of the cation, and then we'll write out the name of the anion afterwards. Good. All right, very good. So basically what you'll be doing is you'll be answering these four questions in your head. Okay, so let's go ahead and let's practice this, and let's do this. So again, don't write out these questions, you guys, and I hope that you don't. Okay, but you do have to make sure then that you're thinking about this as you go through. Okay, all right, let's go ahead. Let's do this next one here. We have then this particular compound here. First question then: is this compound binary? Okay, well, first of all, I'm sorry. Let me step back a little bit further. You got to once we start chapter 8, you'll have to be able to answer this question as well, and that is this compound ionic? Okay, and I haven't asked you that question because we've only dealt with ionic compounds, but absolutely, you have to ask yourself, and maybe you should start practicing this now, whether this compound is ionic or not. So how do you recognize that this compound is ionic? You look at the elements. Okay, do you have a metal and a non-metal in this particular atom and in this particular compound? The answer is yes. Your metal is here. Sn is the symbol for the metal, okay, and then F is the symbol for the non-metal. And then you can go ahead and answer, is this a binary compound? Yes, because you have then one element here, and hopefully you recognize that Sn is the symbol for tin. And then you have the second element here, which is the element for fluorine. Now, again, we are counting elements, not atoms, because if you counted atoms here, what you're going to notice then is you have 3 total atoms. Okay? We have 3 total atoms. But again, in order to answer the question, if it's binary, you're counting how many elements there are. So you have one element there, which is tin, the second element there, which is fluorine. Okay, so is this particular compound a binary compound? Yes, it's binary because you have 2 elements. Again, 2 elements, but this compound is made up of 3 atoms. Remember, the little subscript here tells you how many total fluorines, and the implied subscript here is 1. So you have 3 total atoms in this particular compound, but this compound is comprised of 2 elements, tin and fluorine. So this is a binary compound. All right, so let's go ahead. The name of the cation, Sn, then is the symbol for tin. Okay. So this is the tin cation. Now, this is where you want to be careful. Okay, so is this cation a transition metal? No, the cation here is not a transition metal. However, it is one of those 4 representative metals that I told you, I think it was on Thursday of last week, that you have to be aware of, because there are 4 representative metals where we also have to include the charge. Okay, we have to indicate, we're going to use the stock system name as well, which means that we need to know then what the charge is. We need to include the Roman numeral here. So we got to know what the charge is on this particular cation here. Okay? And so how do we go about doing that? Okay, and this is where you have to remember what we did last week. Okay? All right, so we got to go back to the formula here, and this is where you got to make sure you are aware of this. You got to go back to the formula here, and we got to remember a couple things. Okay. Okay, so first of all, you got to know then that the anion here, okay, the anion is going to be fluoride. Okay, so let's go ahead and let me go ahead and we'll get back to this in just a moment. Okay, let's continue on. Okay, and then we can work our way backwards. Okay, so the name of the anion then is going to be the fluoride, okay, anion. And remember, the stock system only applies to the metal. So we don't have to worry about the fluoride here. Okay. So before we name the compound, we need to know what Roman numeral goes in here. And how do we go about doing that? Okay. Well, we need to figure out what the charge is on this tin cation right here. And how do we do that? Well, we got to work backwards a little bit here, because what we have to make sure we remember then is that, remember, with the fluoride ion here, okay, the fluoride ion is an ion with a one, with the -1. Okay? And this is why we started out today going over this. You have to remember this, because if you can't remember this, it becomes very difficult to do the rest of it. Okay. All right. So in our formula here, in the formula for fluoride ions, we see then that we have two fluoride ions. Okay, so we have two of these here. That's what that little symbol 2 means, which gives us a total charge of 2 minus. All right, we have a total charge between these two fluoride ions. Okay, between these two fluoride ions, when you add the charges together, we have a 2 negative charge. They contribute a 2 negative charge. We know that all ionic compounds have to have a net charge of 0. Okay? And so therefore, this particular tin ion, there's only one of the tin ions. Okay? It must have then, if there's only one, okay, it must have then a charge of 2 plus. Okay? So that's how we can determine then the charge on that particular tin atom, and thus the Roman numeral that we need to include in its name. Folks, this part here, what we did here is with the analysis of the charge and making sure that the compound is neutral. We will do more of that tomorrow when we talk about how we write out the formulas for these compounds. But already you see then that you have to be able to understand what this formula tells us. Okay. All right. So with that said, then this is the name of the cation now. So it's tin2. Okay. And this is the name of the fluoride, the anion. Okay. And in order to write down the name of the compound, now that we've done the hard part, we're just going to write down the name of the cation, which is the tin2 cation, and include in that the name of the anion, which is fluoride. And so the name of this compound is going to be tin2 fluoride. And so you got to make sure that if you have to include, if the particular cation requires that you use the stock system, you name it using the stock system, you got to remember to include that Roman numeral. Okay. All right. Let's go ahead then. Let's do another one here, and let's do. We're gonna keep practicing this. Okay, let's do another one. Okay. And so please make sure you get the homework done. And I'll give you a chance to practice this a little bit more. Okay. All right. Let's take a look at this compound here, and let's. I'm gonna go through these questions a little bit more quickly so that we can work on a part of it that I think is gonna take a little bit more time, and that is the writing out the names of these compounds. Okay? These ions. Okay. All right, let's first of all answer the question, is this a binary compound? The answer hopefully then for you is going to be yes. Okay, 2 elements here, 3 atoms, 3 total atoms, but 2 elements, tin and oxygen. We have that tin again. So the name of the cation here is going to be tin cation. So we're going to write down the name of the metal. This is going to be the tin cation. Is this metal a transition metal? No, but we already saw then that tin here is one of those 4 representative metals that you have to include a Roman numeral. That means you have to use the stock system to name. So we got to figure out what the charge is on this tin. Let's hold off on that for just a moment, and let's go ahead and deal with the anion here. Okay, so the anion here then is going to be the oxide anion. Okay, so this is the oxide anion. Okay, all right. So now that we have that, let's go back. What is the charge on this one? Now, first of all, we saw how we saw that the tin can form the 2 plus ion. Okay, so is that the same here? This may not necessarily be tin 2 plus, so don't assume that. Okay, so let's go ahead to start out with then. Let's take a look at what we do know. We know the oxide anion here. Okay, we know the oxide anion being 2 minus. Okay, So we need to determine the charge on this cation here. So we do know what the charge is on the oxygen anion, the oxide anion here. And here we have two of them. We have two oxide anions. Get started, you guys. Let me go and finish that. Okay. We have the two oxide anions for a total charge of 4 negative charges. Okay. And again, we have to remember then that all ionic compounds have to have a neutral charge. And here we see that we only have one tin atom ion in this one. And so therefore that one tin atom must be able to cancel out this 4 negative charges here. So it must have a 4 positive charge. Okay, 4 positive charges. So this is going to be then the tin 4 plus ion. So we're going to include the Roman numeral 4 in that one. Okay. You got to be able to attain these charges here. You have to be able to do that, especially when we tomorrow when we start talking about transition metals. You have to be able to do that. Okay, so let me go ahead and finish this up here. And so therefore, to write out the name of this compound, write out the name of the cation. It's going to be tin 4. Okay, and then the name of the anion, which is the oxide. So this is the tin 4 oxide compound. Okay. All right, so we've run out of time here. So what we will do tomorrow, what I'm going to do tomorrow then is we're going to talk about, we're going to practice writing out the names of these binary compounds more, okay? Writing out these binary compounds. And then what we're going to do then is we're going to write out we're going to work on the formulas, okay? And then we're going to talk about the non-binary compounds. We're going to try to cover that tomorrow, okay? All right. Have a good rest of your day, folks. And like I said, if you have any questions about this, please practice it. Stop by this afternoon. Stop by this afternoon after my 7th period class at 1:30, or stop by tomorrow. Stop by tomorrow during my office hours, or stick around after I dismiss everyone on Thursday to watch the lesson, ask questions about this. But you got to practice this. Okay. All right. Have a good rest of your day, then, folks. And I will see you, folks. Let me go ahead and say this before I dismiss everyone, before I forget. Okay, and I will see you folks on in the video in lesson tomorrow, and in person I'll see you on Thursday. Okay, I'll see you. Bye.